Okay, so in this video, we're going to take a look at identifying dependent systems. Right. So in the previous section, we looked at inconsistency, or the previous page, we looked at inconsistent systems. So now we're going to take a look here when we have two equations, right, and they actually represent the same line. So at first glance, when you see these look like two very different equations of this system, right? But what we can see from its graph is, we notice both of these are graphed here, is that these actually represent the same line, right? So what we have is a dependent system, right? In other words, that there is no unique solution. Any point that happens to be on this line, y minus 2x is equal to 5, is also a point on the line negative 3y plus 6x is equal to negative 15. All right, so now what if I try to solve this like I would algebraically any other system of equations? What would that look like? How would I represent the solution? Okay, so looking at this, I'm going to solve by addition, and I think if I multiply through by 3, we could see I'm going to rewrite the system. We get 3y minus 6x equals to 15. And then here we have negative 3y equal to negative 15. So when I add these through, we get 0 on the left, and we also get 0 on the right. Now, here is where the main difference from this type of system versus the inconsistent is that whereas before we got a false statement, here we have something that is true, right? So that means that any ordered pair that works for one equation will also work for the other equation, since they're representing the same line. So we have an infinite number of solutions. Now, in terms of a set, right, so the way we can represent that is the solution to this is any ordered pair xy such that x and y follow this rule, y minus 2x is equal to 5, right? So as long as that holds, any xy that satisfies that equation, and again, you could have chosen the second one, that would have also been valid, but this is just one way to represent using our set builder notation. Okay, and this is what you do when you have what's called a dependent system or an infinite number of solutions.